Howdy, I'd like to take 5 minutes of your time to talk about how to get graphical support for your derivatives. Your TIs are not able to compute symbolic derivatives unless you have the TI-89, but they are able to provide the graph of the derivative of a function. So we're going to use the TI calculator to get the graph of that prime, and we're going to compare that to the graph of our calculated f prime. And if those two graphs match, then we have support for our answer. That's it. So how does this happen? Well, let's take, for a concrete example, f of x is equal to x cubed minus x. And the instructions are to find f prime and provide graphical support for your answer. Well, finding f prime is easy. At this point, you guys are experienced enough to know to go term at a time and get power rule 3x squared minus power rule 1. So that's simple enough, although my handwriting is still bad. There, 3x squared minus 1. But what we'd like to do is to confirm that this answer is correct by looking at the calculated version of the graph of the derivative of f of x. So what we're going to do is we're going to let y1 equal the derivative that we calculated, and then we're going to let y2 equal the numerical derivative of f of x. So let me show you what this looks like. We go over here to our calculator. We let y1 equal 3x squared minus 1, just like that. And then we're going to let y2 equal, and here's where we use a calculator function. You hit nav and go all the way down to option 8, right there, and we get in derivative. Now, there's a visual difference between the TI-83 and the TI-84, so let me talk about that at this time. On the TI-83, what you're going to see is this, y2 equals in derivative of. And on the TI-84, if you have algebraic notation enabled, then what you're going to see is this, dd blank of blank at blank equals blank. The bottom notation is a little bit easier to understand, but both of them are going to work. The top one here is waiting for a function value, followed by a comma, followed by a variable, which is always x, followed by the point of differentiation, which in our case is going to be x as well. The comma button is found right above 7 on your calculator. And so in our case, because our f of x is equal to x cubed minus x, then on the TI-83, you would type in y2 is equal to in derivative of function x, x. And what this means is that it's going to take the derivative of this function with respect to this variable at this point, which is x. Meanwhile, you're going to supply the same information on the TI-84, but in a different format. You're going to say that this is ddx of, well, let me write it down here. On the TI-84, you're going to say y2 is equal to ddx of x cubed minus x at the point x is equal to x. And since my emulator is a TI-84, let me do that at this time. I'm going to go over here and I'm going to let y2 equal ddx of the function x cubed minus x at the point x is equal to x. And then, error syntax, go to. A syntax error means a spelling error, so let me see where I spelled something wrong. This one's okay. If I hit graph, it's going to complain at me maybe. Here comes y1. And here comes, I hope, y2. Yeah, it wasn't a syntax error after all. And you'll notice that the graph of y2 and y1 are an exact match. The one graph lies on top of the other. So that means that y1 is equal to y2 at all points x, as near as we can tell. And I have strong evidence that these two are the same function. And that's how you provide graphical support. See you later.